Good morning, friends. As we know, we are doing problems of pressure in fluids from concise physics books of class 9. This problem is about hydraulic brake, as we have seen in cars and all. So the question asked, what should be the ratio of area of cross section of a master cylinder and a wheel cylinder of an hydraulic brake so that a force of 15 Newton can be obtained on each of its brake shoe by exerting a force of 0.5 Newton on pedal. So I'll show you. Well, this is how a hydraulic brake looks like. You have the pedal out here. This is the pedal where you will be applying the force, and there's a special fluid which is normally red in color, and it goes and normally flows like this, so this, and then goes inside this and puts a pressure on both this piston, and then this piston in turn puts pressure on the wheel, and the wheel get stuck. So that's how is the working of this. So now what are they asking is, what should be the ratio of this the pistons actually. What would the ratio of this area of cross section is, how much would be this portion and how much would be this portions. Okay, so this is what the question asks. So let us assume that the cross section area of near the pedal, the cross section area of the piston be whatever x, and so this is x and this is y. It doesn't matter how many pistons, how many brake shoes are there in point B1, B2, B3, B4. The pressure everywhere will remain the same. So we know that from Pascal's laws, pressure is nothing but force by area, and it will remain the same in this point, this point, this point, all the points, it will remain the same. So if the cross section area of point on the pedal, where this is x, meters square, and this is y meters square in each B1 and B2, so we can write for pedal, like if you put P of x, because x denotes the cross section area of the pedal, we put that P of x as pedal, and the force that's given out here is how much? The force that is given out here is 0.5 Newton, and let the area is x. Now for the point B1 and B2, where the really brakes are there, and if the cross section area of each of the brake is y meter square, so what we can do is P of y, that is where the brakes are, is given as 15 Newton, okay, by y. So according to Pascal's law, Px is equal to Py, because pressure is transmitted equally, like through this red fluid, this pressure is transmitted equally and hitting out here and hitting out there. So that's how it works. So it's totally equal. There is no diminishing, there is no change in pressure. So Px equal to Py. So using this Px and Py, this formulas, and if we just put it out here in terms of Px equal to Py, where Px is nothing but 0.5 Newton by x, 0.5 Newton by x, and Py is nothing but 15 Newton by y. 15 by y. What are they asking? They are asking what is the ratio of x is to y. So we are putting x this side, okay, and we are putting 15 down below. So we are getting 0.5 by 15 is equal to x by y. So if you just drag it out here, so and we can, for this decimal we can remove this decimal here, and we can add a 10, because 0.5 is nothing but 5 by 10. So if we just do this, 5 ones are 5 and 5 threes are 15. So 1 by 30 is what is x by y. So if you just write it on the left side and right side, so x by y is nothing but 1 by 13. So what is the ratio? If you write in a ratio format, that is x is to y is nothing but 1 is to 30. Okay, this is the answer. This is the answer. That means if I have to transmit a small force of how much, 0.5 Newton from the paddle, and multiply it so that at the brake shoes it is 15 Newton, we have to have 30 times more cross section at the brakes. Like here, it should be 30 times more the size of the brakes. Obviously the paddle is a smaller one, we always know it's a small, where we just size of our own feet, so that we just press on the paddle, and then this is like we press out here on the paddle, and then suddenly with this mechanism of transmission of pressure through the hydraulic fluid, it can stop a big car, like a half-a-ton car. It can just stop at the fraction of a second. But if you go deep into and check out how the brakes are made, this are much more bigger than our paddle, right? It's not 1 foot, because it is stopping the entire car, one in each tire, so one in each of the wheel, and it just holds the wheel together. So that's how it works, like but the principle is very simple. Like it's like there's a Pascal's law. Just at every point in any kind of fluid, the pressure is same, no matter where, no matter what, and we can really multiply force. It's like some kind of a lever. Okay, I'll come by with more problems. If you have any doubt in this problem, just write your doubt on the comment section on our YouTube channel, and I will come back to you in future videos. Thank you.